There are two ways to associate the imported Pineburn vectors with the Pineburn ecosystem. One way is to copy each vector to the ecosystem. This is called hard linking, and we've done it in previous tutorials. It works great for a few vectors, but is very tedious and inefficient for thousands of them. The second way to associate vectors to ecosystems is to dynamically link them with a search query. Go to the Land Cover Task mode if you're not already there and expand the Ecosystems category. Open Pineburn Ecosystem. On the General page, Vector Placement section, select Link Operations. Select Query, New Search Query. This will open the search query window conveniently named Pineburn. The default filter is set to search the appropriate database objects. The Filter Criteria page sets the conditions for searching the selected database objects. We're going to use the Shapefile attribute for ecosystem type ecos, so select it from the Attribute field dropdown. Ecos. This is the search query for finding Pineburn vectors, so make the ecos field similar to Pineburn. We could also use equal to and type in Pineburn in capital letters, but similar avoids problems caused by case issues in the original shapefile. Back in the database editor, select one of the dems to deselect the PB vectors. Search query, general page, select items now. This is going to test our search query. We must have done it right because all 9 PB vectors are selected as they should be. We now have a search query selecting all those Pineburn vectors, so let's go ahead and remove Pineburn from the environment. Open it from the Scene at a Glance, Pineburn, and remove it from the list. Confirm. Now the only thing that is rendered within the environment is grassland. Pineburn ecosystem will be rendered with the search query. Save the project and render a main preview. You shouldn't notice much of a change in the view except for the fact that we now have the vectors rendering around our Pineburn ecosystems. Let's go ahead and remove those from render. Database editor, select all those layer members, Pineburn. Back on the properties page, we have this column for render. Just go ahead and check or uncheck one of them. They will all be unchecked for rendering. Save the project again, render again. The next thing we'll do is use species percentage attributes to drive the relative distributions of ecotypes within the Pineburn ecosystem. This is where thematic maps come in. They map attribute values to component values. Bring up the ecosystem editor for the Pineburn and turn to the foliage page. The overstory ecotype will be the dominant foliage species, and the understory ecotype will be the subdominant species. Select the overstory and turn to its parameters page. The density is currently a static value. Select Thematic Operations and create Thematic Map. The data page is where we assign the attribute to map. This is the overstory, so choose DOM Densit, that's the dominant density, and that's it. Back in the ecosystem editor, select the understory ecotype. Its parameters page, again, it has a static density. Let's create a thematic map. Once again, in this case, we're going to map the subdominant density, or subdensit. That's all there is to it. Let's just open another main view in the upper right quad here. Save the project, render a preview. The foliage densities are different in the two views because the left main view was rendered when the density was controlled by the static values, which was about 50 stems per hectare. The right view we just rendered had the mapped attribute values, which have a variety of values. If you'd like to see what those values are, or in general if you want to display the vector attribute information in a render, right-click on one of these forested areas, and you'll notice that a new point tab will appear in the lower Seen at a Glance pane. Here you'll see the vector name, its attributes, layers, and components. So if you're curious about what the densities are in these areas, just go ahead and right-click and you can see what the subdominant and dominant densities are.